Hi, my name is Markus. It's Sunday afternoon, so last day of FrOSCon. We're almost there, so let's finish up with some fireworks. And now we're talking about some piece of legislation, so what can be more exciting on a Sunday afternoon than a topic like that? Yeah, I'm a software developer. Here's some coordinates about me, and that's more or less everything that you need to know. By the way, please use Mastodon and not some of the other social networks. Today I'd like to talk about a research project by the name of AI Cockpit, or rather KI Cockpit, because it's a German research project. And it's about the AI Act. I don't know if anyone heard about that legislation. It went into effect, I think, this year. And especially those two articles. And I've learned from some lawyers, it's articles, not paragraphs. It's a big difference. Don't ask me what kind of difference, but so that's the battle plan for today. First of all, I'd like to introduce you to the AI Act, and that's a very, very brief introduction. I don't know how many thousand pages that is in total. And also into what I call the problem, what eyes anyhow, and why are they so problematic in terms of correctness. Then there's a little bit of commercial in here about the team that I work with. I run a company by the name of Zarbock, and I do that in order to introduce a real-world example and then explain how AI Cockpit is supposed to work, because that's a piece of software that shall control and keep humans in control of AI systems. And then we look into the open source implementation that we built, some core concepts, a little bit about architecture, and then there's a quite long list of open issues and questions where we need feedback from people that are using a cockpit, and then obviously some Q&A. Usually when I give this talk, I want to place some questions in the head of the audience. You don't need to answer that, but keep them in the back of your minds. And I think the most interesting question is the first one. By the way, how many of you are software developers? All right, so that's a good set of questions, because for software developers, the question is that system actually using AI? It's fairly easy to answer. For the rest of humanity, I always claim that they can't tell the difference if a software system is sufficiently complex enough. So if you look at an ERP system controlling a company, is there an AI component in there? And does that question actually matter? When you want to know as a citizen, what is the system actually doing? What kind of decision does it make? And then for the technical folks, questions like, do you run AI systems for yourself? And the other questions, do these systems make decisions, and how do you know that? All right, so when you have those questions in the back of your mind, let's jump into AI Act. It's a piece of legislation by the European Union, and again, that's a very brief introduction. And then understanding AIs is a very complicated question, and that's also a very brief introduction to that question. First of all, to get everyone on the same page, do we have classic engineers in here? Electrical engineering, mechanical engineering, physicists? Okay, yeah, well, that counts as... because everyone with a proper technical education obviously knows this. So for every system that I put in the world, I say, all right, this is what the system is supposed to do. This is kind of my target parameter, and I also provide you a margin of error. And so that means everyone that looks at that system knows, all right, that's what it's supposed to do, and that's the accuracy that I can expect. What's the accuracy of ChatGPT? And the question why, or the reason why I put this in here is I think there's only one good definition for what is an AI. AI systems are those for which I can provide this kind of definition of correctness and also the margin of error. And that's kind of obvious because these systems do very complex things that cannot be broken down into numbers. But at the same time, that makes it very difficult to understand, are they working actually correctly? And I want you to keep this in mind. By the way, usually when we talk with engineering students, I said, before we solve these problems from computer science, don't use AI in machinery that is moving around and can potentially kill people. That's something that you should be able to solve. And also, the other consequences is, now how do we decide that AI systems work correct? And the only answer is measuring, which is a very bad thing, because just consider, the usual cat example. You have trained a model that is able to detect cats. What's the confidence that you know that in the next image that the model has not seen yet is actually detecting a cat? And the only way to measure that is by answer that is by measuring. So testing and testing and testing, and having statistics. By the way, also if you're interested in going into that technical field, the confidence that models provided means nothing. It's just kind of a self-reflecting number that the model is confident this is by 78% a cat and by 12% a telephone booth. And so that means in terms of correctness, nothing. So one of the definitions that you can do is for what is an AI is a system for which you can check correctness only by measuring. And I hope that everyone agrees that that's a very, very problematic situation to let technical systems make decisions, if that's your point of reference. Now, you could, by the way, don't worry, yes, it's formulas. Please stay here. It's just an example for another way that won't work. Because in mathematics, there's another way to prove things is by construction. If we look in the technical details of a system, let's look at the mathematical building blocks, how it works, and then now we're all convinced that if I do all that, how this system, by the way, works, we will look into in a bit. And then we're all convinced that whenever I use the system, the outcome will look like this. It will have certain mathematical properties. And now we're convinced that this is working correctly. And that means, if we follow that approach, I give you all those parameters of all those mathematical formulas, and now you're convinced that the system is working correctly. I don't know. I don't think that anyone would agree with that. The problem here is first of all, there is no mathematical way to look into large AI systems like that. And I claim even if there were a way that we could prove correctness that way, it wouldn't help because 99.9% of humanity, or 99%, don't have a mathematical education to know what's going on here. So as you may know, in computer science, there's a huge research field of explainable AI. So they try to explain why these systems actually work. And you would be surprised how much is absolutely not clear at this point in time. For example, how do transformer models store facts? That's open research. So even if there were a mathematical explanation, its results or the mathematical parameters that you would provide to the regular public, to the like regular people, it don't help them to understand how and why this works. So yeah, by the way, this is from the master thesis of one of our students, which will be published in 4 weeks, and you can really look forward to it if you're interested in computer science. So AI Act. Obviously, there's kind of a public interest to understand how these systems work and to create lawful and publicly checkable means to control what these systems are doing. And there's a number of reasons why that's necessary. If you listen to the talk from Frank von Nextcloud yesterday, there was a picture of a current American president. There's obviously a lot of reasons why we need to understand how these systems work, because so many of those services are provided outside of the European Union. And if you offer them to users over here, you want to keep in control what's actually going on, especially if these systems are making decisions. And if you look at agentic AI, the latest hot topic in there, it's really bizarre what kind of responsibility people are handing over to those software systems if they only would know how little we know how they actually work. Yeah, that's very interesting. I found it very surprising that AI Act is one of the first pieces of legislation where the European Union come up with a piece of rules and regulations, and it has become national law right away. So the usual approach was there is a kind of a framework provided by the European Union, and then each member state has to translate it and into national law. And that meant that you don't have one piece of legislation, but 26. is it 26? I think with the Brits they were 27, right? And from a technical point of view, and also from, I'm a CEO of my own company, that's a very good thing because it means one rule for all of the member states. Yeah, and so the fundamental idea here is to put in place a number of rules that will allow users to get information how AI systems are used, what kind of decisions do they make, and also keep humans in control of what's going on, and if necessary, correct decisions that these systems are making. And then there's a definition of high-risk AI systems, and I will come back to that in a sec. And the research project that we did is focusing on these 2.5 aspects. First of all, human oversight. So that's kind of the emergency brake in trains. Unfortunately, things with software are not that easy. Also, most engineers would agree shutting off technical systems without any precautions is also not a very good idea. Anyone living next to a nuclear power plant or a chemical processing plant, I guess, would agree. And the second thing is transparency for deployers. The word deployer, does that mean something to anyone in here? Because that's something that if you're not a software engineer, you don't know. In software engineering, deployment is a well-defined term. So it's the process in getting a software live and providing it to end users. And the reason why this is so well-defined in AI Act is, I guess that's my assumption, that most of the AI systems that we're using today are not from the European Union. And that means many companies will and organizations will use AIs where they are just deployers. So they are the ones that actually serving the systems. And AI Act requires from anyone doing that to be in charge of what's going on. So you can't say, I don't know how that works. You have to look to that guy in the US. This won't work. So AI expects from you that you collect the necessary information. If you look in the technical reality of what's going on, that might be a quite naive request, because that will be very difficult to achieve. Also, good luck enforcing certain transparency rules in other legal zones of the world. Maybe you heard of all the interesting laws, let's say, that are in place in the US in that area. All right, so another aspect that's interesting, if you are one of the persons that like to read legal texts over the weekend, you'll find many quite vague terms. If you ask lawyers, they say, well, that's nothing unusual, because if you introduce new legislation, then the first trials in court will clarify what each of those terms means. From an engineering perspective, I don't know if I like that approach, especially if software systems make decisions that affect people's lives. 2 years later, you have a court decision that say, well, that would have been illegal. Well, the consequences are already there. Yeah, so there's a number of web pages. By the way, one of the interesting parts is to find out which web page is actually the official one from the European Union. And I'm pretty sure it's this one. But if you Google for AI Act, you'll find a lot of these. And so, just for some examples for vague terms, is what is an AI system? Yeah, it's a system that's using one of the techniques listed in Annex 1. So that's an AI system. Yeah, but yeah, I mean, I fully understand why lawyers would do such a thing, but the thing is obviously it's not easy to define what an AI system is and what it is not. Another interesting term that I found is purposefully manipulative technologies. I don't know, is advertising not exactly purposefully manipulative? So, I always look at those texts from an engineering perspective. So what's the stuff that I need to build that is working exactly as designed? And so, so that's going to be very interesting 2 or 3 years ahead of us with interesting court judges. And then that's maybe a more interesting aspect. AI Act also makes certain practices illegal. So it's not that they are not encouraged, but they're illegal. And so yeah, one of those things, and this is just an example, is social credit systems. That's what the background is for the first one. I don't know, does everybody know what a social credit system is? So it's, I think, something that they invented in China, and yeah, want to make sure that everybody is smiling enough when in public. Yeah, and something like that is explicitly illegal. And this is also be very interesting how this evolves in terms of, I mean, if you look at social media, they're targeting towards many goals that could be summarized with a social credit system. But anyhow, yeah, high-risk systems. I only put an excerpt in here. The question is why did they make this differentiation? Now, obviously, there's, I don't know, thousands of smaller companies, public entities, non-profit entities, and you can't expect from all of them to put in place all the regulations that are in AI Act. And so this is an attempt to focus on those systems, first of all, systems that have severe consequences, and also are working in certain areas. So, for example, if you work in critical infrastructure, I don't know if you run an energy system, something like that. Whenever you put a piece of AI software in there, obviously you're a high-risk system. What also is interesting is anything around HR processes. So when you use AI components to make decisions in HR systems, which, by the way, is explicitly illegal. That's, by the way, an area where I think the next years will show if it will be possible to enforce those rules, because in many American companies, the HR department will be completely get rid of humans in the next year. That's something that's unavoidable, given the economic system of the US. And so it will be a question if we can keep that in Europe. All right, so, and that means for every system that falls into that category, you have to apply or implement all the rules defined in there. And then I usually, when we have this debate, I ask again, looking from a general public view, what's the difference? If you look at letters that you get, decisions that authorities or companies make for affecting your life, how do you tell the difference between AI systems and just a badly configured ERP system? And so that's also something that is, for me, a big question mark, if that can be achieved with that regulation, and also if that problem is addressable at all. Yeah, and then also for everyone that has ever worked in software engineering, I really like this quote from Grady Booch, that the history of software engineering is one of rise levels of abstraction. What does it mean? We put software layers on top of software layers on top of software layers, and that's going to continue. And all the AI libraries and concepts that we have these days, there will be just another layer. And that means the systems that we're building will become ever more complex, and this is never going to stop. And so that means AI is not the end of the story by all means. I guess in 2 years there will be fancy new technology. But the difference is we now let AI components make decisions. Something like, here's access to my bank account, manage all my finances. Which I find really scary, not that these systems exist, but that people actually use them. So good luck. And the main question is how can we establish trust that the services that will be available in the commercial area as well in the area of government activities, how can we trust them? And trust not in the sense, yeah, let's trust them, but make sure that they work within a certain technological framework. All right, now I slip in a little commercial part. And you will see at the end why I try to frame this like a commercial. Just imagine there's a startup from the nice city of Wolfsburg. I don't know, who of you has heard of the city of Wolfsburg? All right, yeah, so that's the city that we actually live in. And in this little shack, Annette founded the company and wrote the first piece of code, Florian and myself. And yeah, so this is our team. Hannah and Edgar are writing their master's thesis currently and work on anomaly detection. And we work in this area. So we looked at cities, and maybe that's a big surprise, but living in Wolfsburg, we think that traffic in modern cities is not very good managed. And we have some ideas that maybe reduce individual traffic, but let's not dive too deep into that. And so that's the background that we're looking at, and we already have some interesting project going on here. And this is kind of the core of the sales pitch. AI-driven data analysis enables intelligent traffic solutions. Here, this is a real-world example that we did where an accident occurred, and then you can do something immediately, sending someone to help, but also create some statistics to make sure that this is not happening again, or when you have areas in your city that are unsafe, that they are improved. And we built a lot of software, by the way. That's something that yesterday I found really interesting when you work in public projects. I think one of the titles yesterday was a lot of public money, but not an awesome lot of public code. We're different. Everything we build is on GitHub. And each of our projects starts with, the first line of code is already published. We will talk today about these three components. These two I need to introduce because they use two different kind of AI components, and then I'll explain how AI Cockpit can be used to make sure that these are working as supposed. And all the other software components that we built, if you're interested, you can have a look. Oh, and by the way, if you add a minus trainings in here, if you run lectures at universities, we have tons of material introducing programming languages, microservice architecture, and stuff like that. So that's all publicly available. All right, awareness engine. It's an AI system that is maybe not the latest, hottest topic, but is nonetheless an AI using system. And the core idea is at one end you pump in video streams, and at the other end pops out geolocated objects. So there's a number of components that detect objects, track them, and do some mathematical magic and say this object is at this geo-coordinate, and from that you can derive speed and direction, stuff like that. That sounds very simple. It's, I think, 15 or 18 components, and it took us 2 years to develop that. It's fully open source. If you want to use it, feel free to do so. And obviously with that you can already implement a lot of interesting functions, things like how many containers are in that locations, what's the in and out flux of vehicles and people in that area. So all the fun things that you can do with statistics. And in here, in those two components, we have something that is listed in Annex 1. So there's neural networks in here, convolution neural networks. So this is kind of an AI component. If I would use PowerPoint, which I don't like to use as a PDF, you would see now a video. So just as an idea, you have video material on that page, but what we're actually doing is we're putting dots on a map. These are cameras in the US, and we only show those images to explain to people how all the stuff works. In Awareness Engine, at this point, there's no longer video material necessary. And for everything that we do from here on, we don't need video material. And this stuff is using inside of cameras. So just in case someone is asking some privacy questions. By the way, you can ask me afterwards. We did that in Germany, so we did it all with all the authorities in that area. And this is some other pieces of software that we have built in order to work with that data, and I want you to focus on that part here because that's the output of Awareness Engine. So there's no more video material in it, it's just trajectory through space and time. And so this is where the second layer of AI is now added. It's called anomaly detection. And by the way, do we have mathematicians here? Okay, that's good because so once we had of this kind of trajectories, we collected tons and tons of material because there's no longer image material in there, so you don't have a data privacy problem. And then we started to look for statistical interesting things. So this is a Gaussian distribution in 6 dimensions, and then you can very easily find that's a vehicle going backwards, that is a human that is no longer moving, and or in an area where humans usually are not, and stuff like that. But classic statistics is powerful, but it's slow and not so powerful as these things. So the second approach is training a convolutional neural network. And what it does is kind of predict what's happening next. If you remember the complicated slide from the beginning, what this does is it looks at something like 12 or 24 hours of trajectories, and then is then able to predict what's happening in the next 10, 20 frames or seconds. And every deviation from that is then considered as an anomaly, and then it can cluster these and say this is looking weird in the same way as these other 3 weird trajectories. And that's really, really powerful, because what you can do is find stuff like that. People driving on the wrong side of the road, entering in the wrong side of a roundabout, and then continuing on the wrong side of the road, losing cargo. And at this point, by the way, I could get a lot of very easy laughs, because over that intersection you have something like 30,000 vehicles per day. And if you ever heard about the standard distribution of probability theory, with 30,000 events every day, you get every kind of idiot every day. We have videos from all of them. But already, it's funny, but also kind of scary, right? So it's something where it's very easy to imagine how can you abuse that kind of technology. Yeah, and so this is what we're actually trying to find is accidents. Not in the sense of evaluating accidents, but shorten alert times and response times. So we work with the firefighters. By the way, this is the city of Carmel in the US, in Indiana. And so we work with the police department and the firefighters to faster detect accidents, because people involved take minutes to alert police and firefighters, and that these minutes literally can save lives, especially when you have harsh weather conditions. All right, last aspect, once you have this kind of anomaly detection, you can start comparing areas of the city. By the way, that's a US city that is 137 roundabouts and only 2 intersections with traffic lights, and they have the lowest rate of accidents in the US. They also have kind of the lowest average speed, which might be the better correlation. If you ever go to Carmel, there is, believe it or not, an association in the United Kingdom for the appreciation of roundabouts, and they have a yearly calendar, and Carmel has won this award. And so if you ever go there, if you want to make friends, say, oh, you have particularly beautiful roundabouts. But jokes aside, obviously you can make interesting statistics and say, all right, in this area you have a lot of anomalies where pedestrians and bicycles are involved, so you really should look into that intersection if you can do something. Now, who is in? Wasn't that a nice and fantastic AI startup pitch? So that was something that we would can tell to venture capitalists, and would you like to buy share my companies? My company. And first of all, we're on a run and manage business, and we intend to do so. But the point is how do you know that this stuff actually works and does not do 15 other things that we won't tell you? And the answer is you can't, unless you do what I'm about to show next. And so the idea here is trust but verify. Anyone heard that term before? Yeah. Yeah. Well, you have to know, if you Google my name, you will see that I come from the social democratic camp of politics, and that's a quote from Ronald Reagan. And usually people from my background do not quote Ronald Reagan, but it was being used when talking about disarmament. And so they said, we write a contract that you will destroy this kind of nuclear weapons, or we'll put a satellite in orbit and check if you actually do that. And both of those aspects are important. Trust is that is from our team background, is everything that you do needs to be open source. Every line of code, all training data, the labeling concept, the training algorithm, everything needs to be open source. If it's not open source, it's from our perspective impossible to establish trust. And at FrOSCon, we had a number of talks dealing about the question, where do the large transformer models get their data from? That's something that we intend to do. And by the way, if you're in Berlin end of September, there's a large conference there, which I show in a minute, and you will see that we publish all training data. But verify is the second aspect. So when systems are running, we want to make sure that you control every decision, or you can control every decision that a system is making. And so let's jump into, first I need to introduce the research project, because the German taxpayer paid for all of that. And so you ought to know. So 2 years ago, we joined a research project by the Federal Ministry for Labor and Social Affairs. And the idea was here to look into a piece of software that keeps human in control, as I would say, complex software systems in which some parts are using AI methods, because there are no individual AI systems. It's usually landscapes of systems. And we had 3 field labs: medical care, HR, and mobility. By the way, you can find out more on the webpage. And our field lab was mobility in communities, and the focus was therefore on building user interfaces and APIs into those system landscapes, and exploring if you can build something that is somehow generalizable. As you can imagine, from financial decisions, medical care, controlling traffic, it's an open question if that stuff can be controlled in the same way. Yeah, and there's also was some embedded scientific research around that, and from the University of Stuttgart, there were a neuroscience group that observed humans while they were using our software, and there was an absolute fantastic experiment, and that was really interesting. All right, so before I explain a lot, let's jump into a demo. Oh yeah, so by the way, that's the part that I mentioned. If you do lectures, we put everything on GitHub, and maybe also as a proof that this is not just a supposed to be open source company. We are. So yeah, so there's all the stuff that we're putting on GitHub. So that's the demo environment, and let's log in. Yeah, so the idea is that here we built a demo environment that is trying to implement the AI cockpit concept for a multitude of scenarios. Obviously, our scenario was traffic, but there's also, actually we should call it waste management and not trash. And one of the ideas, or the core idea, is that each of the components of a system landscape, by the way, these modules here comprise one AI using system landscape, because, as I said, usually you don't have a single of these. And so object tracker would be one of the parts of awareness engine, and anomaly detection is the actually interesting one, because that's the one that's making decisions. And let's see. And the core idea here is, and that's kind of a key takeaway from my talk, next to the fact that we're talking about a serious problem that we should deal with, is that's what we came up eventually. We say we have in one condensed dialogue on the left-hand side the interpretation of the AI system, what the AI system thinks is real. So we have some image, material, documents, whatever, and here we have a kind of classification. That's the problem that I see, or a problem I need to address. And as you can see, you can also manipulate that. So that's the outcome of anomaly detection. And as a human operator, I can correct that. On the right-hand side is the idea that a system not only is looking into reality and try to interpret it, but also executing actions. So that's kind of the overall goal, that these two things will be done automatically. And again, here's the stuff that the system can do, and I can correct that. I can remove methods, and I can also completely abort this entire incident and say, we'll do this manually. And that's the first hypothesis that we put out, that this is a good approach for any kind of AI system to control what it's actually doing. The second thing is and that's something that's the kind of an consequence of AI Act, you have to be, as a human operator, be able to say these things should be done automatically, these I want to check, and these you are not supposed to do. We started with 3 so-called autonomy levels, and obviously you can imagine that might be a little bit too non-granular, but that's something that I'll come back in a bit. And also an hypothesis that we did for AI Cockpit is that these automation levels are put to the actions, but not to the interpretation of reality. Again, that's a very engineering way of looking at things. We think that making yourself blind will never help. You know, turning off sensors, turning off an interpretation of problems that I see, it has no consequences, but it degrades your human abilities to look into what a system is doing. At the same time, sending a police patrol somewhere is a consequence, because if it's actually a firefighter that you need and not a police patrol, that's a problem. Also, that police patrol could be missing at another place where it's actually more needed. And so we put that on the actions of a system. Now, I think on one of the slides I put the idea that you also need some kind of an emergency shutdown. I think I mentioned earlier. If you have an autonomy level per action, then it's quite difficult to tell to a human operator, is this system in an automatic mode or is it in a manual mode? Because now it becomes more differentiated. We don't think that a global automation level makes sense. But then again, that's one of the questions that we want to answer by actually using a system. By the way, one of the consequences is we have kind of an emergency brake over here. It's not red and big and glowy and shining because we think, again, engineering, it's more likely that people will say, you will never send out police patrols. I want to stop that right away. I want to take back control to a human operator. But the other stuff, like, I don't know, sending messages to broadcast stations, that is something that you can still do. But again, that's an hypothesis. Another interesting aspect, I mean, it depends who you are, is transparency about the used components. So usually corporate legal departments really like that. You can here create Excel reports. We used Excel because, well, it's everywhere. We proposed LibreOffice, but yeah. By the way, if you want to build a LibreOffice report, pull requests are very much appreciated. So go ahead and help us. And so does everybody knows what an SBOM is? A software bill of material? If not, it's kind of a breakdown of all the components that a module is using. That was first invented to look into things like vulnerabilities in terms of security, also license problems. And all the SBOM standards are now going towards machine learning and AI aspects, like training data set, which evaluations did you do for a component like that. So that's something that we wanted to include here. Finally, this stuff can be used for many application domains, or at least we think so. And so the next one that we're doing is for waste management, and together with the city of Wolfsburg, we will do something like that. And as you can see, this is all random test data. Actually, I think the first one is kind of correct here. Yeah, so this is synthetic data. Currently, we're in the process of collecting real data from trash collecting vehicles in Wolfsburg and training models that can detect trash in the streets, especially the kind of trash that needs to be taken care of immediately, like, I don't know, paint, batteries and stuff like that. And then propose what needs to be done. And yeah, so that's going to happen next. And then last example, and I have to show you this, it's maybe not as useful for real world, but that's from a master thesis from the university in Aalen, and the engineer's name is Uta, and she built a toy factory that you can put in a box like that. Yeah, and we're using that in lecturing and explaining how we can use that here. So we built some software components that are checking this, and everything is actually moving. So there's engines in there, and it's a real little factory. Anyhow, that's great fun when you're an engineer. But let's move on with the other slides. All right, to wrap this up, the core idea of AI Cockpit that we build is explaining decisions and not algorithms. Again, that might be from the legal perspective or the public debate that turns out to be not sufficient. But we think that it's the best approach to keep a human operator in control, because something like this is a traffic jam where it is obviously, I don't know, a political demonstration or whatever it is, it's easier for humans. So it's a level of abstraction that we can cope with. Whereas the parameter of that algorithm is 15.6 and it's supposed to be 5. I don't know if that's helping anyone. Also, this module-based combination of decision-making capabilities is something that we did. You could also argue, I don't know, if you look at a automated vehicle, that you define decision-making on the entire vehicle, not on individual functions. And depending on the use case, that also might be something that we need to add. But currently, we're focusing on a module base. Yeah, and then the idea of that central dialogue, to have all information in one place to check if the interpretation of the system is correct and if the actions selected are also fitting. And obviously one of the results or requirements that you need is that for all AI systems out there, you need standard interfaces. This is the kind of data an AI system needs to provide in order to be checked that way. Yeah, then we use autonomy levels. And one of the things that we didn't finish in the research project, but we're still working on it, is when I said an operator can say, this is completely wrong, the decision is wrong, the action is wrong. Obviously, there's a way to feed that back and make sure that this kind of mistake is not happening again. But for that, we don't have an algorithmic component yet. As you can imagine, depending on the underlying AI system, telling the company that runs ChatGPT, here your algorithm is wrong, do something, is not so simple. And so that's kind of an open question. Yeah, and in summary, currently what we do is the human stays in the loop. So you get every, by the way, decision is the scientific term for I've come to a conclusion that something needs to happen, and the actions. And by the way, if I would give that talk in our office, then actually some flashlights would simulate, now I send out a police patrol or a trash collecting vehicle. And by the way, pro tip, if you're a big conference, don't use fire alarm simulators. It's great fun, but you are in a lot of trouble. Yeah, this is a technological conference, and so here are some very brief details. The application itself is a super boring application. We build it in Java and Spring Boot on the back end and React.js on the front end. I don't know, we didn't have that many software engineers here, right? I don't know how you stand on the Python issue. Yeah, I like Java, and I know I'm old, but yeah, it's working. And so a database, and then min.io to drop binary content like videos, images, documents, stuff like that. And then when we defined interfaces for the decision and action part, and yeah, and if you're interested to run this stuff, we're using Helm charts and Helm files to pump the entire application onto Kubernetes clusters. Yeah, and just one technical term here, we try to follow a microservice architecture approach, and that means next to the central web application, where actually I forgot to put in the human here that's operating a software. Well, I'm a software engineer, so humans, you are over here. And then there's a bunch of components, the transparency API that is extracting all the SBOM module information version numbers, and also the decision API. That is something that we kind of fully implemented in the project. The action part we just simulated with Raspberry Pis and flashlights. As you can imagine, that's kind of difficult to, I don't know, mock up in a laboratory. And just in case you're interested in SBOMs, we also built a small component where you can send a CycloneDX SBOM in, and you get back an Excel or PDF report. 2 years ago, stuff like that wasn't existing, and now we are looking into the standards because there's a lot of tooling around that. Yeah, and then database, here we put in the binaries and a little bit of authentication, authorization. If you're interested, all APIs are defined using OpenAPI, and you can find them here. And we also published a Java library to Maven Central that is implementing all the data types for those interfaces. There's also a Python library. We didn't manage to publish it to PyPy. I don't know. No one was really in the mood to do that. Yeah, and how is that sitting on top of the example that we built? One thing is anomaly detection is attached to the awareness engine. So here's all the video processing. Oh, and by the way, this is just some PowerPoint architecture. In reality, there's a cut here from embedded systems in the field, and somewhere over here you enter a data center. I wanted to spare you all the details. And then AI Cockpit is sitting on top of those components and extracting data. We can use it, do that extraction by hooking into the central communication bus, but also using REST APIs, which is kind of dependent on how you deploy it. Autonomy levels, I just wanted to highlight that the 3 that we choose is just one idea. I don't know, are you aware or have you ever heard about the autonomy levels for self-driving cars? I guess. Yeah, and so, we're from Wolfsburg, so that topic is something that you not really can avoid. So these are the autonomy levels, and one of the things that one could think about is that we use that kind of granularity. We thought that, no automation and 5 automatic levels may be quite overkill, but yeah, it's something that you can do. Also, the questions, do we do this per system or per module, is still very open. Yeah, and this is some information about the transparency stuff. The background here is it's necessary that this stuff is there. I think rarely people look into actually the software bill of materials and look at the 400 libraries that you used in order to build that specific component. But an interesting takeaway is these are the 2 main standards that are currently existing, CycloneX and SpeedX, I guess is it pronounced. And both of them are extending this list of libraries by ML, machine learning aspects. Things like, here's the training data, that's the latest point in time where this model was actually trained. And here are all the evaluations, kind of unit testing for models. And so we're trying to update that and no longer build that on our own and use existing technology. All right, so that kind of brings me to kind of a conclusion. There is still a lot of open questions. So as I mentioned already, one of the interesting questions is when you use AI Cockpit, do you grab the information that you need from an AI Cockpit component, or do you request that all AI software systems implement a certain interface? If you want to have an analogy, in every vehicle, there's a plug called OBD2. Maybe you heard of it. It's usually under the steering wheel. And there is a protocol defined that if you're in a garage or a workshop, you can request certain data from a vehicle and it has to answer in a certain way. And it's for exhaust information, and vehicles are supposed to answer that truthfully. And I will not dive into that. And you can do that in 2 ways, enforcing that information or ask the systems that they send it to you. Another thing, currently the implementation is that the standard use case is that a decision action transition is blocked by a human operator. Is that a good concept, especially if you talk about problems where you build a software system because humans are too slow? And that's obviously something, why do you invent software on computers? Because computers can do stuff faster than humans. So the module system duality we had in certain places. Here's an interesting question. I think we had that in one of the talks earlier also. Do I take a bill of material from the actual component, so I request that it has an interface that I can ask? Or is it enough if I look into GitHub and get the latest version there? Which means I have to believe that whoever is deploying the software is putting everything that's actually running on GitHub, which is, I think, maybe a quite naive assumption that that's happening. One of the very interesting questions that I hope that I get some feedback from that audience is what kind of licensing model should we use? Currently, everything is published under AGPL v3, which is a super tough open source license because we want this component to stay open source, but it's also a kind of a viral license. So if you put it into your system landscape, every other system needs to be published as well, which is obviously not a good idea, but how can we overcome that? We're software engineers, not lawyers, so if anyone has a good idea, please let us know. Also, this stuff will not really work with embedded systems that have no online connectivity. So the human terminating killer robot cannot be controlled that way. And also one of the questions that we had in that project time and again is this, yeah, all right, so now I have 20 modules that will decide if you get promoted in a company. And one of them is using AI. What about the 20 other ones that are using kind of regular algorithms? Shouldn't you get some information about them as well in order to understand what the tiny AI component is actually doing? That's also an open question. Yeah, summary of what we did. There's more examples. By the way, if you want to access the test system, shoot me an email and I create you a user for you. We also have some ideas how to use that in kind of self-healing cloud environments where code is generated and then applied and needed to be checked by a human operator before the stuff is being executed. But that's the general approach. And last aspect, if you happen to be in Berlin on September 30th, together with the waste management agency of the city of Wolfsburg and the city of Wolfsburg, we will present everything that we did. You will see that all of the code is open source. And expect some fireworks, because these guys run some very interesting vehicles and we put some software on it, and yeah, it's great fun. Especially if you're a software engineer and not used to work outside. Well, in that area you have to work outside, and that's going to be interesting. And with that, I'd like to thank you and ask for questions. By the way, you can ask in German. Yeah.
It's fine.
We need more AI.
Okay. Hi. Thanks for the talk. I have a question about the humans who will sit in the cockpit, or what assumptions did you make about those humans? What kind of training should they have, or do they, is there a human 24/7 in the cockpit?
That's an excellent question. Actually, I should have talked about that. Two things. First of all, one of the assumptions is it's not someone with a degree in computer science. That wouldn't be very much helpful. If you ever happen to be in the beautiful city of Aalen in southern Germany, they are building a real cockpit. We call it the Starship Enterprise Bridge project. And to answer exactly that question. So what kind of knowledge do you need to have to work with that? It's obvious if you have a traffic management system, if you have a system that is controlling chemical processing, like a regular guy will not be able to work with the output. An understanding of the application domain is obviously necessary. If you happen to be riding on an airplane and the pilot is, dying of a heart attack, and you put one of the passengers in the cockpit, I don't know if that cockpit is helpful. And so, yes, you have to do some of these assumptions. And our guideline was application domain knowledge, but no computer science knowledge. I hope that answers the question. All right. Cool. More questions? Yes.
Okay, thank you. Could you be more specific or elaborate a little bit on this part where you said AI Cockpit explains decisions, not algorithms? What does that mean specifically?
Yeah, maybe let's jump back into the demo environment. So if you look at that situation here, that component needs maintenance. And obviously there's a super duper clever algorithm that is observing their factory and comes to the conclusion this component needs maintenance. So now I can explain to you how this algorithm is working. So it looks at these kind of parameters, it uses phase space, it uses trajectory space, Hilbert space, and now these parameters have crossed a certain threshold, and therefore the model decides it needs maintenance. Or I can tell you the algorithm wants maintenance. Does that explain the difference? And so the idea is this here is completely omitting the way the system has come to that conclusion. But it presents you there's a picture, and the idea was that something here is broken, and that you can kind of understand that decision and make your own assessment if that's correct.
Okay, but how do you do that? Because in an AI model, how do you know how it comes to its conclusions?
Well, you don't. But the point is this: here, maybe in traffic, the situation is more clearer. The hypothesis is you collect all the data that the AI had available to come to the conclusion. And so here you can check if that's correct. Now, obviously, the question leads to the point, what about situations where the application domain is a bit more complicated? And the answer is, we'll see. It's something that we need to actually try this out, if that kind of control mechanism, and that kind of leads to your question as well. What kind of human sits in front of that dialogue and actually can understand this kind of decision? Especially, I mean, if you think of the manufacturing example, I worked 10 years for a certain automaking company and did a lot of production IT. Those systems are freaking complex. How much application domain knowledge do you actually have to understand what's going on? And the answer is a lot. And that's, by the way, also something that's personal opinion, where I don't know where this AI age will lead us all, because once you're using AI, you lose your own abilities to understand problems like that. But yeah, so that's the idea. In traffic, it's easy, kind of easy, because you can provide video material. So is this a traffic jam or not? Is there an accident or not? So a human can do this quite easily. But yeah, the factory example is more complicated, because one image probably won't do it. Yeah. Good questions. You really captured the essence of the problem. Yes, go ahead.
I would like to ask a completely other question. How do you finance yourself? Just with the support of the government, or do you have other income streams?
No, we have real customers. So we have real customers. So
okay.
I didn't want to do this as a commercial for my company. So we're doing a lot of software engineering and consulting, and also lecturing and trainings. This is a piece of software that we built within the realm of a research project, and obviously got some funding out of it. And now we're applying some of the software components with the city of Wolfsburg, which are paying us for something different. But it was a good chance to try this in reality. But yeah, we're like a real company. And shares are not for sale.
One more question about the research project. I think on the slide it said that there were also psychologists, for example.
Yeah.
Were there any philosophers involved? Because for AI ethics, for example.
Yeah, maybe let's explain the psychologist first, because the anomaly detection was developed by people from computer science and mathematics, and so their idea of notifying humans is a red dot. And I don't think it comes as a big surprise that the psychology colleague said, well, it's not. And so we thought about like 100 ways highlighting a vector field, what's supposed to happening. Also, when you look at that scenery at night, this sign here is glowing red. And one of the outcomes was everybody's looking over here, whatever happens over there. And so these are all super interesting feedbacks that from a software engineering perspective, we never thought of. So that's important. The ethical part, not really, because it was a focus on an interface idea, so that we can find out, can you do something that's generalizable and that actually works? The ethical part is actually kind of covered by, maybe that's a naive engineering perspective. You can control those systems and you can stop them. And so it falls back to a human operator. Now that might be a kind of a coward position, but that's how the world runs now. At the end of the day, now humans make these decisions, and we have trust that that's a good way of doing things. And so the idea here is to transport that idea on the next level with a lot of additional software components. But in essence, you're right. It looks like that won't be enough. All right. More questions? I think time's up. Well then, thanks everyone. Enjoy the rest of the show, and thanks for listening.